feel free to ask questions as we go. So I am Becky, ologist. I work at Ronan Engineering as one of our sales engineers and regional managers. I have been in the sales business for about 20 years, and I've been doing nuclear gauging for about 11 of those 20 years. So our goal today is to talk about the basics of nuclear measurement and then what Ronan has to offer product-wise. I'm going to try to use just half an hour to 40 minutes of your time. So we'll go ahead and get started. So my goal is to provide an overview of our gamma measurement technology so you will see its benefits and feel more comfortable selling the item. So we're going to do that by going over the theory, our product benefits, the types of measurements that can be made, which are density, weight, and level, generally where the solutions are used, and then some basic safety questions. So what I'm going to talk about is not just Ronan specific, and to start with. With radiation, the question often comes up, where does the radiation come from? So to answer that, we need to go back to our chemistry class and talk about the atom. The basics of that atom, obviously, if you guys remember, may have a neutron, it has a proton, and an electron. And that's a stable atom when it has one of each of those components. Many atoms have additional electrons, protons, or neutrons, and that makes them unstable. With the two atoms we deal with, either cesium or cobalt, those two atoms have extra elements and produce energy, and that radiation energy is what we take advantage of. So the operation theory is the same for all systems, whether it's density, weight, or level. As the process increases, the signal reaching the detectors will decrease. The detector measures the change in radiation or the number of photons it's seeing, and it sends that
John Rutledge
proportional signal back to the transmitter.
Has left the meeting.
That correlates to a signal which sends an output. So what do we mean? We mean that the pulse that's coming to the detector then is converted into a 4 to 20 milliamp that can be used. So here's an illustration. This is the radiation, and as the rays are emitted from the source, they are focused to travel through the near wall of the tank, so that's this wall, the medium or the process, and then the far tank wall to the detector. So any questions so far?
And I was just thinking that irrigation thing I'm working.
All right, we'll go on here. Generally, product features and benefits. All equipment is non-contact. That means it's mounted externally to the vessel, to a pipe, to a conveyor, and it's little to no modifications to that equipment required. It's free from wear and tear. Where are these measurement solutions used? They're most often used when everything else fails, and other measurements might fail because of high temperature, toxicity, installations, design, viscosity, abrasion, high pressure. So what types of measurements can you do with gamma or nuclear energy? You can measure density in a pipe. You can measure weight of a process on a belt or a screw. And you can measure level of the process in a vessel. So for density, the principle is with a low amount of density in the pipe, so these rocks represent density, there's more radiation that gets to the detector. And if there's a high density in the pipe, there's less radiation that gets to the detector. Here's an illustration on the weight principle. It's the same idea. This is the source right up here, and here is the detector here. This is the material that's running along the belt, so this amount is being blocked. Then we're sending a signal to the controller. And then just to illustrate level, this is the source. Here's the energy being emitted, the detector. This is a low process where nothing is being blocked. This is a high process where quite a lot is being blocked. With level, you can also do point level, so a specific area. And you can also do mold level in the steel casters. The fourth type of level that we could measure is an interface level. So that is when you've got more than one layer, as you can see here, and we're measuring the level at each point and giving an output. So what industries might use this kind of technology? Mining, aggregate, power, refining, oil and gas, chemical, metals, pulp and paper, dredging, cement, food and beverage. And the question often is asked or explored is, well, if I'm going to buy this, it's going to hurt me quite a bit, and I don't want to be around it. So I pulled from the NRC website a basic example of annual exposures. So for example, if you're out in the sun and you're at sea level, for a year you would receive about 26 microrem. In comparison, going to get an X-ray of your chest would be 10 microrem. So your annual dosage is less than 1,000 microrem per year. So we'll go on here. That was just an overview of the gamma technology and what the idea is. Now the competitors, I just thought about this. Our competitors that we see are Vega, which was Omart Vega. We see Texas Nuclear, which is now Thermo Fisher Scientific. And we see Endresen Hauser, we see Berthold, and Tracerco. So those are the main competitors. So now what I'm going to go over is what Ronan has to offer from our nuclear division. So our goal here is to provide an overview of what we've got to offer so you can find some applications to sell. We'll do that by introducing the product, illustrating some quick applications, and giving some detail. Next week we're going to just talk about applications, so today I won't be showing a lot. So Ronan Engineering is a privately held company out of California, founded in 1959. We had an office in Canada. was founded in 1975. That's when the nuclear business came into Ronan's portfolio. It was in Toronto, and because of some economics, we closed and consolidated in 2011. We have a facility in the UK, was founded in 1979. They're in Newcastle, England, and they used to do some manufacturing. Now they're just sales for Europe, Asia, and the Middle East and Africa. And then the division that I work for, the Measurements Division, was founded in 1980, and we're located in Florence, Kentucky in the U.S., and we're the hub for the measurements products. So we're able to offer sales, service, technical, and engineering support from all 3 locations. So here's our company is broken into 2 divisions. One is the measurements. The other is display products, and they're now in Valencia. So specifically the products that Ronan Measure has to offer, we offer density measurements, and that's on a pipe. So we're going to give an output of specific gravity, percent solids, API. We're also going to help with mass flow. To do mass flow, we need another signal input from a flow meter, and we'll combine that to give you mass flow. For weight, we can measure the processed material on a flat or troughed belt, a screw conveyor, drag chain, open conveyors, or closed conveyors. For level, we can measure the process continuously at a point or the mold levels, which are in the steel mills. We also offer some radiation monitoring for scrap metal. We just talked about why use nuclear, but generally it's the measurement of last resort when nothing else will work. It's a non-contact measurement because everything is external to our vessel or pipe. It's not affected by obstructions like agitators or blades, extreme process temperatures, pressure, corrosion, abrasion, or toxic materials, caustic, abrasive, sterile processes, violent process flow, changing processes, dust, moisture, pretty much anything that's in a vessel. So we already talked about the theory. So for density, it's ideal for liquid processes when non-contact is required. So these are some images of what it might look like on a pipe. We can mount this on any type of pipe. It's mounted externally with no bypass line needed. It can measure density or percent solids of the slurry. Our goal is to give you a measurement repeatability of 1%. We have on our controller, we have a push button to help calibrate, and we can offer empty pipe monitoring, so we give a signal when the pipe went empty. Sometimes you can't go straight on a pipe because it's too small or it's too large. So we offer density solutions that would go on what we call a Z-section. That's for smaller pipes, generally small measurement ranges, and increased accuracy better than 1%. Sometimes there's really large pipes where people need to measure density. In that case, we don't necessarily make a measurement through the center. We go off to one side. We call that cord mounting. That helps us reduce the source size. There is a specific source that Ronan sells that no one else is able to sell. It's called the low-level source. In the U.S., these are the features. and advantages. In other countries, this is not an advantage that can be sold. We can sell these, but you still have to have someone who is licensed, trained to deal with radiation. So for density, we can put that on pipes from 2 to 12 inches. No leak test or wipe test needed. There's no on and off shutter mechanism. No shutter check is required. No training is required for people to install, relocate, or remove the device. And other manufacturers claim they have a low level, but we always ask the question, do you have a shutter? Do you have to have the shutter check and the leak tests? So here's just some quick pictures of where the devices might be installed. I commented about mass flow a minute ago. Here's just specifically mass flow. Requires a separate flow meter, getting a 4 to 20 input, and then we can calculate the mass flow plus give an output of density and weight. Density and flow. So the next technology solution that we can measure is weight. With this one, instead of looking at it from a left to right perspective, we're looking at top to bottom. The source is typically above the belt, the detector is typically below the belt. The frame goes around the conveyor, so typically there's no modification required. Like I said, it can be used on screws, flat belts, idler belts, buckets, drag chains, incline conveyors. We will give you 3 outputs: weight, rate, and speed. Unlike other weight measurement solutions, it's not sensitive to belt tension. It doesn't need recalibration. And we'll give you repeatability within 1%. So here are just some quick illustrations to start to jog your memory, get you thinking. The weight scales, we use that low-level source very often. Because of that, we can put the source pretty much right above the process. As you can see in this picture, this is the source right up here. We're very close to the top of their process. Our competitors have to do things like this with multiple sources, and as you can see, there's a very big gap in between the top of the process and where the equipment is located. So for continuous level, that's the third kind of thing we can measure. The source and detector are directly on opposite 180 degrees from each other. And we can measure solids or liquids. We've got a wide variety of collimation. This beam of energy, we talked about focusing the energy. We can make this small to very large, and that could give us less sources needed for a very tall measurement. We can make a detector the contour of the vessel. So if you've got a curved vessel, we can help get closer to the bottom and the top of the measurement range. Again, we're doing a 1% repeatability, and there's very minimal maintenance, no components to wear out. So here are a couple photos, installation. For point level, we're finding one specific point giving an alarm in a vessel. And so it's going to detect the presence or the absence of the process. We've got several different configurations based on what the customer might need, whether it's an integral where the electronics is right with the switch tube, or whether it's remote where we have this electronic piece some distance away. We offer double pull, double throw relay, and 1% accuracy. So here's the installation. For mold level, we have over 400 successful installations throughout the world. The highest accuracy we're able to provide is within 2.5 millimeters, and we're giving a process signal every 5 microseconds. We can custom engineer to fit into any slab, billet, or bloom design. Right here's the source, and right here's the detector. A lot of them we put water cooling on because the temperature's hot, obviously in a steel mold. It's got low maintenance required and high reliability. Here's a couple pictures inside a steel mill. Here's just a couple illustrations of what the different detector styles look like. I mentioned we do radiation monitoring. We provide a very minimal analysis of what's in the truck. We can give alarms to say there is some kind of radioactive material in your scrap metal. We would not be able to tell you where specifically it was in the truck, but many places don't necessarily need that. We are using them most commonly with steel mills or scrap yards. So Ronan's components consist of a source holder, which could look like one of these devices. We also offer some that go inside of a well, a dry well that goes inside the vessel, and that helps us reduce the energy size and get through really thick walls. The second component of a system is the detector, and we offer 2 different styles of detectors. We offer, actually there's 3 different styles. I don't have a picture of the other. Oh, yeah, there it is. We have a scintillation detector, and we make that as a rigid product or as a flexible product. We can make the rigid up to 15 feet long and the flexible up to 23 feet long. The thing with the flexible is there's a liquid inside that does freeze. So if you're in a cold environment, they have to heat trace to keep it warm. Or most often we're using the solid detector. We also make an ion chamber, which uses plates that are inside a pressurized argon gas tube. They're very good for high vibration, and we're one of the only people still in the industry making them. The third component of a system is what we call a microprocessor transmitter. We offer 2 different styles. One is called the X96S. This is our most popular unit, and that's because it's got push buttons for calibration. It's very easy to navigate through that key panel. It looks a lot like a heart communicator. It can be remotely mounted away from your system, and it can be used with any kind of Ronan device. We can hook up multiple detectors into there, and we can give many different kinds of outputs. Heart, foundation field bus. We're giving 4 to 20, and you can get up to 8 alarms out of it. The other style is what we call the X96SI. The difference here is it comes in an explosion-proof housing, and it's programmable through a Heart handheld device, our proprietary configurator through the computer, or a web browser. Both of the products either offer AC power or DC power. Here are the outputs. Calibrate through the web browser or through the software and have CSA approval. We won't talk about licensing today. Manufacturing capabilities here in Kentucky. So we make everything in-house. We've got a full CNC machine shop. We have an electronics area that puts things together and prints the boards. Test equipment to ensure that we've got quality standards, and we have a dedicated laboratory for developing new things and increasing efficiency. So our advantage comes from pooling our resources within the facility to bring constant innovation to our customers. Here is a scintillation detector crystal. This is what's inside those detectors. And we put each device through an 18-hour environmental chamber where we run it from freezing to 50 degrees Celsius to simulate environments and to stabilize our outputs. So overall, why nuclear equipment? It's a measurement of last resort when nothing else is going to work. It's completely non-contact, and it's not affected by temperature, pressure, corrosion, abrasion, dust, or moisture. So why specifically Ronan? Because we can customize the product to the customer's specification and application. And our office and facility here in Kentucky only deal with the nuclear technology. So we're not thinking about radar, pressure. So I hope through this webinar I've given you an overview of what Ronan's got to offer, some ideas for installations and gamma technology in general. I'm going to open up if anyone has any questions.
I got reflex scoring already.
Great. So if no one has questions, next week we're going to do application specific. We'll only talk about applications. So thanks everybody for your time. Have a great weekend.